We can do probability or chance experiments involving different types of spinners. So let's have a look at this example here. Here is a spinner, and let's imagine that it's been drawn perfectly in the sense that the R, the Y, the G are all exactly a third. So let's list all the possible outcomes. Well, there are 3 possible outcomes from having this spinner. So if I have, let's pretend there's an arrow there and it spins around. Well, the 3 possible outcomes are red, yellow, and green. They're the 3 possible outcomes. And the question here says, what is the probability of the spinner landing on yellow? Well, there is a 1 chance out of 3. So there's a third chance of it landing on yellow. Here is a spinner, and here is a question. Again, let's imagine it's been drawn up perfectly to scale and that each section is completely even. Are all outcomes equally likely? Well, you can see, let's first off go, what are the outcomes? Well, the outcomes are 1, 4, 2, 5, or 1 again, and then 3. So they're all the different outcomes that we have. And it says, are all outcomes equally likely? Well, they're actually not. Reason being, because we have a 1 here and a 1 here. So it's not equally likely that each number could appear. Number 1 has a bit more of an opportunity to be spun around on. Let's look at a few more questions involving the spinner. We just did this a moment ago, we'll do it again. List all the possible outcomes. Well, the possible outcomes are 1, 4, 2, 5, and 3 being spun up. What is the probability of the spinner landing on 1? Well, because we have a 1 there and a 1 there, there's 2 of them, the probability of it landing on 1 is actually going to be 2 out of 1, 2, 3, 4, 5, 6, a total of 6. Again, I can simplify that fraction, so there's a third chance. What is the probability of the spinner landing on an even number? Well, I can see here that I've got 2 even numbers. That is the 2 and the 4. So we have 2 out of 6 as the probability. In other words, that can be 1 out of 3. What is the probability of the spinner landing on 7? Well, simply put, there is 0 chance. Therefore, we can write 0. Probability of the spinner landing on the 5. Well, I have 1 5 there, and then I have 6 different outcomes. So it's going to be 1 out of 6. Let's look at some experiments involving a normal deck of cards. Cards are often referred to in different chance and probability experiments. So here's some important information to know. In a normal deck of cards, there are 4 suits. 2 of them are red, 2 of them are black. So you have your black suits are spades and clubs, your red suits are hearts and diamonds. And then in each suit, there is 13 cards. So if you can think there, well, that means there's going to be 26 black cards, 26 red cards. 26 plus 26 is 52. So there's 52 cards in a normal playing deck. So, and that 13 cards involves ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. So there will be 13 of spades, 13 clubs, 13 hearts, 13 diamonds. And as you just heard before, okay, in each suit, these are the cards that we have. Okay, so for diamonds, there will be an ace, king, queen, jack, 10, 9, 8, 7, 6, 5, 4, 3, 2 of diamonds. So once more, 52 cards in total, 26 are red, which includes hearts and diamonds, 26 are black, which includes spades and clubs. Now that we know that basic information about a deck of cards, we can start to look at some different probability and chance experiments. Therefore, what is the probability of selecting a red card? Well, I know that there are 26 red cards out of 52. I also know that that is exactly half. So there's a half chance of selecting a red card. So, same again, what's the probability of selecting a black card? Well, I know there's 26 black out of 52. Therefore, there is a half a chance. What is the probability of selecting a heart card? Well, I know there are only 13 hearts. And it's going to be 13 out of 52. And again, if I'm knowing my fractions quite well, I can reduce that again, because that will be in exactly a quarter. So there's a quarter chance of selecting a heart card. What is the probability of selecting a red 4? Well, I know that there is a 4 of diamonds and there's a 4 of hearts, which means there are actually 2 red 4s in a normal deck of 52. So the probability of selecting a red 4 will be 2 out of 52, or half the top, half the bottom, 1 out of 26. So what is the probability of selecting any ace? So it could be a black ace or a red ace. So again, let's have a look. I know I've got the ace of diamonds. I know I've got the ace of hearts. I know I've got the ace of spades. And I know I've got the ace of clubs. So there are 4 different aces in the deck of cards. So therefore, the probability of selecting any ace will be 4 out of 52. And again, I can probably halve that. I can have 2 out of 26. Further again, 1 out of 13. So there is 1/13th chance of pulling out any ace from a deck of cards. So let's have a look at what the probability of selecting the 10 of diamonds is. So that's 1 card from one specific suit, and there's only 1 of those in a deck of cards, the 10 of diamonds. So that's simply put, I have 52 options available, 52 cards. I have 1 chance of pulling out the 10 of diamonds, 1 out of 52.